So, what actually happens when two mountains touch? It sounds like something out of a legend, right? A real clash of the titans. But it's a real question in geology, and trust me, the answer is way more epic than you could probably imagine. Let's dive in and see what the Earth is really up to.
I mean, you're probably picturing this slow, grinding crash, like a massive fender bender on a continental scale. And okay, yeah, there's definitely some grinding. But calling it just a collision, that really misses the whole point. This isn't about destruction, it's about creation. It's not an ending, it's a beginning.
In reality, when these two masses of land meet, it is a profoundly creative act. It's a process that literally builds new landscapes, forges entirely new types of rock, and can even change the climate of the entire planet. This is the Earth's tectonic engine running at full throttle.
Okay, first things first. To really get our heads around this, we have to completely toss out our human sense of time and speed. We are entering the world of geologic, deep time, and things move, well, really, really slowly.
Get this, we are talking about a speed of just a few centimeters per year. That's it. It's about the same rate your fingernails grow. It sounds like nothing, right? But when that relentless, tiny push continues for millions upon millions of years, well, it adds up to something truly immense.
And here's the key thing to understand. It's not actually the mountains themselves that are moving around. The mountains are more like the wrinkles on the surface. The real powerhouses are the massive tectonic plates they're sitting on. As these plates push together, all the crust in between gets squeezed. Geologists have this awesome name for this whole mountain building process: orogeny. It is the force that sculpts entire continents, and you can see it happening right now where the Indian plate is smashing into the Eurasian plate, pushing the Himalayas just a little bit higher every single year.
So what does that squeezing actually look like on a huge scale? I mean, how can something as solid as the ground we stand on possibly absorb that kind of incredible, relentless force?
Well, it happens in a few key stages. First, the plates creep toward each other. Then, the crust that's caught in the middle has nowhere to go, so it starts to compress horizontally. This unbelievable pressure causes the rock layers to bend, fold, and even break, creating huge faults. And finally, all that land that's been squeezed horizontally has to go somewhere, right? So it goes up and down, thickening the crust vertically and pushing those mountain peaks higher and higher into the sky. Now this is where it gets really, really cool. Think about pushing a tablecloth or a rug from both ends. What happens? It wrinkles up, right? You get these upward arches and these downward troughs. The Earth's crust does the exact same thing, just on a massive scale. Those upward arches in the rock layers are called anticlines, and the downward troughs are called synclines. What you're seeing here is the Earth's solid crust literally buckling under pressure.
And this quote just nails the mechanical reality of it. This is not a smooth, clean process. It's a jagged, messy, grinding interlock. You have massive layers of rock being folded, fractured, and then shoved on top of one another, which is what builds the incredible complexity and height of the new mountain range.
But the story gets even more wild when we zoom way in. I mean, forget the continental scale for a second. Let's look at what's happening to the individual rocks buried deep inside that collision zone. Miles below the surface, there's a secret transformation going on. It's called metamorphism. The heat and pressure become so unbelievably intense that they force the actual minerals inside the rock to change. Now, they don't melt into magma, that's key. Instead, they recrystallize, forming completely new structures and, in the process, entirely new types of rock. And here you can see exactly what that looks like in practice. You take a common rock like granite, put it under all that pressure, and bam, it transforms into gneiss, a new rock with these beautiful flowing bands. Or you take limestone, which is a pretty soft sedimentary rock, and it recrystallizes into the much harder, much more elegant marble. The very building blocks of the rock are being taken apart and put back together in a totally new way. Now, of course, the Earth's crust can't just absorb all this stress quietly. The friction is enormous, and the pressure just builds and builds until the rock inevitably snaps. And when it does, that energy is released in these violent bursts. This is what causes constant earthquakes, creates massive fault lines that can run for hundreds of miles, and can sometimes even thrust gigantic slabs of ancient rock right up and over much, much younger layers. It is chaos and creation happening all at once.
Okay, so we've gone from the continental scale all the way down to the mineral scale. So now let's zoom back out and look at the ripple effects. How can this one collision in one spot end up reshaping the surface of the entire planet. Because what it does is it sets up this constant, epic battle. On one side, you have the tectonic uplift, that relentless upward push from the collision. But on the other side, the second that land starts to rise, you have the forces of erosion. Rain, wind, ice, rivers, all working tirelessly 24/7 to wear it back down. The jagged peaks and deep canyons we see are the direct result of this ongoing war between building up and tearing down.
And the impacts, they are truly global and totally interconnected. For instance, you build a massive new mountain range and you can completely alter regional weather patterns, creating rain shadows that might turn a lush area into a desert. This in turn creates entirely new alpine habitats for plants and animals, and it forces huge river systems to carve completely new paths to the sea. The sheer weight of the mountains can even cause the land in front of them to sink down, forming these vast geological basins. It's a chain reaction on a continental scale.
Finally, this whole incredible process leaves behind a story, a permanent legacy written in stone that geologists can come along and read millions of years later.
Because here's the thing to remember. Mountains, as mighty as they seem, are not forever. They have a life cycle. So you have the initial contact, and then this period of peak uplift and building that we just talked about. But eventually, the tectonic forces might slow down or stop. And at that point, erosion wins the war. Over hundreds of millions of years, a towering range like the Himalayas could be worn all the way down to rolling hills, kind of like the ancient Appalachian Mountains are today. And when that happens, you expose that deep metamorphic core that was forged in the heart of the collision all those eons ago.
So the ultimate takeaway here is this. When two mountains touch, they don't just collide, they fuse. They become one single new geological entity, a brand new mountain range with a completely unique history and a complex story of its own formation that's literally encoded into its transformed rocks, just waiting for us to find it and read it.
It really makes you think, doesn't it? The ground beneath our feet feels so solid, so permanent. But this whole process shows us that even the mightiest peaks on Earth are just a single frame in a very, very long movie. It leaves you wondering, what so-called permanent landscapes that we see all around us are really, right now, just works in progress, slowly transforming into something else?